episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I think we got ourselves a pretty good and interesting one today, as you probably saw if you read the title of this week's episode, and we are going to get into that later on in the episode, but first, let's start off with our trivia question for the week. And this week's trivia question is, what year did the first Raspberry Pi get released? So what was the year that the first Raspberry Pi got released? And that is your trivia question for the week. And before we get into our cybersecurity tip, there is a piece of cybersecurity news which I want to touch on, which I think is absolutely incredible. And that is that Apple is unveiling their post-quantum encryption scheme for iMessage, which is pretty fantastic. They're joining the ranks of other companies such as Signal, Amazon Web Services, Cloudflare, and Google in implementing post-quantum encryption algorithms, which is awesome and fantastic to see because that is basically ensuring, at least to the best of our knowledge, based on what NIST, the National Institute of Standards and Technology, has put forth, that quantum computers will not be able to break this encryption. And the reason why that's so important is because if you're not super up to date on the whole post-quantum thing, in a nutshell, basically what it means is the way that we currently generate like public and private keys, the most common way is through something like RSA, which is a public key encryption scheme, which basically means you have two keys, you have a public key and a private key. And in essence, the way that they're generated is by taking two extremely large prime numbers, multiplying them together to get a result, and using that result to essentially get your keys. So in essence, right now, it's pretty much impossible to deduce what those prime numbers that were used to make the key was. So if you have the public key, it's basically hard. It's basically impossible to determine what the two prime numbers were to get that made the key pair, so you can't deduce the private key. But the private key basically has that information in it, so it's really easy to deduce the public key. But the thing with quantum computing is it basically completely trivializes that with Shor's algorithm, which is a way to essentially break this encryption scheme and factor prime numbers and whatnot. So that is why post-quantum cryptography is something that is really, really important, and it's really awesome to see that more post-quantum algorithms and encryption schemes are being developed by the day. So what Apple said about it was, with compromised resilient encryption and extensive defenses against even highly sophisticated quantum attacks, PQ3, which is what they're calling their algorithm, is the first messaging protocol to reach what we call level 3 security, providing protocol protections that surpass those in all other widely deployed messaging apps. So basically what they're referring to here is Signal, not too long ago, also released their own post-quantum encryption algorithm, but that, I guess, is only at level 2, whereas Apple is claiming theirs is level 3. But regardless, it's awesome to see that they are adding this post-quantum encryption to the iMessage protocol. And specifically about how it's designed, Apple also mentions that it's designed to mitigate the impact of key compromises. According to them, they're limiting this by limiting the number of past and future messages that can be encrypted and decrypted by a single key. So specifically, they're planning to rotate the key scheme that's generated and basically rotate that key every 50 messages at most, and at least once every 7 days. So essentially ensuring that your key is always rotating, which I mean, I guess on the one hand, that's pretty good. I mean, it's kind of like changing your password frequently. If you frequently change your password, then, if someone were to get a database dump that has your password in it, then it's going to be outdated information. I'm not entirely sure how it works, like, because typically with encryption, you have to have the key in order to decrypt. So if you use a key to encrypt something and then you get rid of that key and start using a different key, you won't be able to decrypt the thing you encrypted. So I'm guessing they'll probably just have this rotating key scheme for like encrypting new messages, and so you'll still be able to decrypt the old ones, because that would, in my opinion, be kind of silly if you could only read your 50 most recent iMessages or your iMessages within the past week. That would be kind of silly if you were only able to do that. Now, the support for this PQ3 is expected to start rolling out to the general public in the next OS updates. So that's iOS 17.4, iPadOS 17.4, macOS 14.4, and watchOS 10.4, which are supposed to come out sometime in March. I'm not exactly sure on the exact date, but the thing that should also be interesting about this too is if this is going to be a specifically iMessage only thing, or if Apple is going to try to include this in RCS messages as well, since they did mention that they would support RCS, although I don't think they really mentioned much about what encryption they would support with RCS, since I know RCS allows for encryption, but Apple didn't really mention much about the kind of encryption that they would use, so it's a little unclear as to if they will include this PQ3 encryption scheme in all of iMessage, including RCS, or if it'll only be for iMessages. Personally, I'd like to see them include it with RCS somehow, whether they open source it and make it available for others to implement into their RCS services, messaging applications, or what have you. But anyway, I have a link down in the show notes to the blog post that Apple put out about it. It goes super in depth into how the algorithm works and like how the thing works. So if you want to have some light reading, you're more than welcome to check that out. And with that, let's get into this week's cybersecurity tip. We've talked in the past about trying to ensure that you have good firewalls and good network segmentation and all that good stuff. But I want to kind of hit on that again this week, because as much as we love, as Homelabbers, as much as we love having access to all of our things at the same time, in reality, we should be segmenting things so things that don't need to talk to each other don't actually talk to each other. And I'm kind of a hypocrite when I say this, because I honestly am not the best at segmenting my network. I've done it a little bit. I have some network segmentation, but in all honesty, probably not as much as I should have. But the reason why you want to segment things is, we mentioned previously that having your management interfaces on the same, network as all of your other services is generally a bad idea, because if one of those other services gets compromised and the attacker can make some lateral movement to your management interfaces, well, then you're kind of toast, because they have access to everything. Because if you've used any kind of hypervisor solution before, you know that if you can get access to the console, like to the web UI, for instance, you basically can get access to every single machine, because it's essentially like you're plugging a monitor and keyboard and mouse directly into it, and you have console access to that system if you can get into the web UI. Like, for instance, I know Proxmox has the ability where you can select whatever VM you want and get a direct console into the system, whether that's a terminal or if that's a graphical user interface, if you installed one of those. Regardless, you get complete access to the system, even if that system is on a different network than your management interface, in this case being Proxmox. So that is one reason why you definitely want to make sure those things are segmented, because if your management interfaces gets compromised because someone compromised another system that happened to be on the same network as your management interfaces, well, then you're kind of out of luck. So that's why you'd want to segment those. But it's not just Proxmox too, like the VMware Solutions has it as well. And I'm pretty sure basically every single hypervisor has this. Heck, even if you use like VirtualBox, which is not necessarily seen as a hypervisor in the same sense that like Proxmox or VMware ESXi is, because those are seen as type 1 hypervisors, essentially running everything on bare metal, whereas VirtualBox is what we call a type 2 hypervisor, essentially meaning it's running on top of the operating system layer, so there's just an added layer between your virtual machines and the bare metal. So those virtual machines don't get direct access to the bare metal. But even still, with VirtualBox, if you have a bunch of virtual machines running in VirtualBox, you can click on them and get into the UI for them and control them, even though technically they're on a different network than what VirtualBox is running on, depending on how you configured your network settings, I guess. But regardless, if you have access to the hypervisor's interface, you have access to all of the servers running on said hypervisor, which is definitely why you want to segment things. But another reason why you'd want to segment things is if you aren't the only person living in your house, because, principle of least privilege, number one, but also two, you don't necessarily want like your roommates or anyone else messing with some of your sensitive information or servers that you're like playing around with and tinkering with, because one thing you definitely don't want to do is be tinkering around with something which just maybe happens to knock out some other portion of the network, like maybe your Pi hole or your DNS or something. And then the rest of the folks at your house do not have internet anymore, and they will get mad at you. So that is potentially another reason why you'd want to have things segmented, to make sure that the stuff you're playing with does not affect the things that other people are using. Another one would be is if you have a lot of IoT devices or any IoT devices, those being Internet of Things devices, you definitely don't want those having the ability to talk to your sensitive devices like your NAS or your management interfaces. I guess if you're self-hosting like cameras or security cameras or something, you could make the argument that they would need some kind of access to maybe not specifically your NAS, but some kind of storage solution to be able to record that footage that they record in case you ever wanted or needed to play it back. That could potentially be a use case, but still, definitely you should have that stuff segmented. But another thing that you kind of want to think about when trying to determine what should be on what segments is, does this server need access to these other servers? So for instance, does your Git server need access to your VPN server? Maybe it does, maybe it doesn't. Does your development server need access to the Git server? Probably. So, maybe those two should be on the same network. So these are some of the kinds of questions that you'd want to ask yourself, and then based on that, you can set up access control lists or ACLs in your firewall or VLAN settings in order to control, what data is flowing where, what servers can talk to what network, that kind of a thing. And the reason why this is important too is because it also helps prevent that lateral movement. So if someone were to somehow infiltrate your network, if the server that's running only has access to 2 other servers, it definitely limits what the attacker can get access to. Whereas if you have everything running on the same network, the attacker has free reign to access whatever they want to. So that's why you'd want to segment things and have those access control lists in place. So this, like I said, this can improve your security from potential lateral movement. But another thing it can also do is reduce the network chatter, because if you've ever run like WireGuard or not WireGuard, Wireshark or some other kind of network analyzer, one thing you'll notice quite quickly is how many requests you'll get from all the various devices on the network being like, I have this IP address, who has this IP address? I have that IP address, who has this IP address? And they can be very chatty. So in order to cut that down, reducing the number of devices on the network can definitely help with that. Another thing I've also heard that can also lay credence to this is I've heard issues of people, specifically with Proxmox, with very chatty networks where some of the Proxmox nodes will have issues communicating with each other because of all the communication on the network. So it's generally suggested for a performance perspective to make sure the Proxmox network that the nodes talk to is on its own separate network, again, kind of adding credence to why you should segment your network in order to have direct communication between the Proxmox nodes and not have any of that interference and network chatter. Personally, I've never experienced that, but I know there have been documented cases where people have experienced that. Maybe I'm not running enough services, although I don't know, I feel like I'm kind of running a fair number of them, seeing that I think I'm in definitely high teens, maybe even low 20s of VMs that are running across my Proxmox nodes. So I don't know, maybe that's not enough. Maybe it is. Maybe I've just been lucky. I don't know. Maybe I just haven't noticed it. But yeah, anyway, you should definitely segment your network, and I honestly should probably do a better job of segmenting mine. And that is your cybersecurity tip for the week. Before we get into the nerdy things, I think I need to confess something, which is that I am a stupid, redacted, smelly nerd. And of course, I paraphrase that and use redacted rather than the actual word that was used, because this is a family-friendly show, and the bomb, as it's known, starting with the 6th letter of the alphabet, is not exactly what I would call family-friendly. So as a little bit of context, let me explain what I'm talking about. So this all stems from some absolute fire memes that have been circulating around the developer community. It basically sums up to be Reddit drama. But the reason why I even bring this up in the first place is because it's actually kind of relevant, because it actually deals with programming and software development in general. Because normally, like, Reddit drama, like, I don't even keep up with it. I don't care, don't know. But seeing that this was programming, I had to get to the bottom of it and figure out what was going on. So the drama originates from the GitHub subreddit, where someone posted the following comment. And it is titled, "I am new to GitHub and I have lots to say." And so that's the title. And this is what they say. "I don't give a redacted about the redacted code. I just want to download the stupid redacted application and use it. Why is there code? Make a redacted exe file and give it to me. These dumb redacted think that everyone is a developer and understands code. Well, I'm not, and I don't understand it. I only know to download and install applications, so why the redacted is their code? Make an exe file and give it to me. Stupid, redacted, smelly nerds." Yeah, so a lot in there. A lot had to be redacted for the sake of this being a family-friendly program. Um, but this individual was quite annoyed that there was no exe for them to download. Now, the Linux chads out there are probably laughing to themselves, being like, what even is an exe? Because exes, of course, only exist on Windows, at least the actual .exe format. Now, you can create like a shell script on, like Mac OS or Linux and rename it to be .exe and it'll run, just fine. But the typical .exe format is, of course, exclusively to Windows. But the reason why this is kind of why this was memed so hard was because the project that they were referring to was completely programmed in Python. And if you've ever used Python before, you know that there is no exe. You don't compile Python code into an exe. Now, there are tools out there that can essentially, I think, package everything together and create an exe, but it's definitely far from standard. And typically, you just run whatever the main file is, or if you only have one script, you just run the one script, and that's how it works, because typically exes are relegated to applications that are compiled down to machine code. So for instance, if you create a C++ program, for instance, on Windows, and you compile it down, it will be compiled into a .exe file because it got compiled down to machine code. But yeah, this person was quite fired up, of course. They really wanted that exe, apparently. And yeah, so that is where the logic behind me claiming that I am a stupid, smelly nerd, because I have also been I have also provided code to GitHub, Python code too, nonetheless, without any exe tied to it. So I guess that basically makes me a stupid, smelly nerd, at least according to this person. So I just thought I would get out in front of this one before all the backlash and all the people trying to come for me, with their fiery torches and their pitchforks. But I did read that allegedly this whole post might have been bait. And to catch anyone up on the term bait, if you're not familiar, since I know that is very internet-centric, basically it means that some people are alleging that this person that posted this post in the first place was essentially posting it for the sake of provoking a response. Like, they knew that this would get people fired up and make some great responses out of it, and that's why they did it. Regardless, though, there have been some pretty fire memes on the subject. Yeah, pretty fantastic. So yeah, I just thought that was kind of funny. Lightened up my mood for sure. And with that, let's get into what nerdy stuff have I been up to this week. Now, before we dive into today's topic, let me share some recent news from my home lab. Over the past few weeks, I've been working on setting up a new project, spinning up a large language model. Now, I know what you're thinking. It's I'm not exactly a big tech, person. I'm not a big tech company, and it isn't something better left to big tech, because with the right hardware and some determination, it turns out that creating and running your own large language model is within reach for the home lab enthusiast. So without further ado, I decided to ask my new language model for an introduction to our podcast for today. So here we go. The model said, "Hello and welcome to another episode of Home Lab Hacks." They got the title wrong. "Today we are going to discuss an intriguing project that combines the words of artificial intelligence and home lab experimentation. Our host," your name, has recently set up a large language model in his own lab, and he will share his experiences and the challenges he faced and the potential applications of this technology for Homelabs. That's right, we are going to talk about my journey setting up this language model, as well as its capabilities and the possible use cases in the context of a home lab. So whether you're a seasoned home lab enthusiast or just starting out, we hope you'll find this episode both informative and inspiring. Stay tuned for more details on my large language model adventure. As always, if you have any questions, comments, feel free to reach out to us on social media channels through our website. Now, everything that I just read there, from the nerdy things music till right now, was completely generated by the large language model that I currently have running in my house. So while all of that was pre-canned, pre-generated stuff, I didn't write any of that myself. I just happened to read it. I thought it would be kind of a cool way to introduce the fact that I set up a large language model in my house, in my home lab, by asking it to essentially kind of break the fourth wall, if you will, and basically give me an intro, telling it, so basically me telling it to give me an intro of it asking a large language model to give it an intro, if that makes any sense. It made a lot more sense while I was thinking about it before I said it. Maybe I should have asked the large language model how to explain that better. But anyway, yes, so I did get this working. So I use this open source project called Ollama, which basically allows you to download all various kinds of AI models and run them locally, aka on your own hardware, so you're not giving all of your juicy data to the big tech companies, which that got me very intrigued. So of course I had to try it out. Now, based on what I've read about Ollama, you don't actually need any kind of like GPU horsepower in order to get up and running with it. But of course, I figured since I have a GPU in my lab, I have a Tesla P4, which I talked about on a podcast episode a while ago. I have that running in my R620, and generally it doesn't really do anything. It just kind of sits there. The only real use it gets is if I feel like generating some images with stable diffusion on it, or I feel like testing out some CUDA programming, which every time I try to run CUDA programs on that GPU, it's basically done instantly and I don't even have to. So I don't remember if I mentioned this or not. I think I did, but I wrote an entire bash script for the GPU virtual machine to control the fans of the R620. So because the Tesla P4 card doesn't have any fans on it, so it has to be cooled passively through just the airflow in the server. So and for whatever reason, it doesn't communicate its temperature to the R620 itself, probably because it's not a Dell specific card. So the R620 doesn't know that it needs to ramp its fans up. So I wrote a script specifically for the to cool the GPU, basically to take the temperature of the GPU and adjust the fan speed percentage accordingly. So anyway, I don't even have to run that script when I'm using CUDA programs because it's done so quickly. If I'm running the NVIDIA SMI tool to check the usage of the card, I'll see like a quick blip of it being used and then it's gone. Like it's there for a couple seconds tops and then it's just done. Honestly, I don't even know if it increases the temperature at all, and if it does, it's like maybe a single degree before by the time I can run the next test, it's already back down to what it was before. So it basically nothing. So using this Ollama thing, I'm actually able to put it to good use, put the GPU to work. Now, it doesn't work quite as hard as it does with Stable Diffusion. With Stable Diffusion, it gets those fans roaring. Now, with Ollama, it also gets the fans ramping up too, except because how quickly it's able to generate the text, probably because it's GPU accelerated, it doesn't actually, it definitely gets hot, and if I wasn't using the script, it would overheat if I asked too many questions, but it definitely doesn't get anywhere near as hot as it does with Stable Diffusion, because when using Stable Diffusion, it's just maxing out that GPU while it's trying to generate those images. But I thought that was something that was really, really fun, and if you'll recall back to the title of this episode, because I have this large language model now running in my Homelab, I decided to get its input on Homelabs in general, which we will get into a little bit later in the show. But before we get to that, I wanted to touch on a couple other quick things. And I mentioned, it was either last episode or the episode before that, where compilers will essentially rewrite your code for you, and why that's not necessarily a bad thing. Because I talked about how, for whatever reason, the macOS compiler was totally fine compiling and running code that should not have worked, and it still did it anyway. But I have another instance of why compilers are actually clinically insane, but in a good way, because I decided to write the most basic implementation of, well, I guess it's technically not the most basic implementation, but the most basic useful implementation of multi-threading in both C and C++. So I wrote a C variant using pthread, and I used a C++ variant using the std thread. So basically the goal here was to create a program that would sum up a number. So if you gave it, say, 1 million, it would sum every number up to 1 million, including 1 million, and return you the sum. Now, this obviously takes quite a bit of computing power once you get up to really, really large numbers. So this is a perfect use case for multi-threading, because you can divide up the task evenly and have each thread calculate its own section, and then merge all those sums together and add them up, and you get your final sum. So fantastic use for multi-threading is what I thought. And I crafted this multi-threaded solution. This O of n solution runs however large n is, that's what time it runs in. And I figured doing it multi-threaded, you essentially divide what should still technically O of n, but you divide n by the number of threads. But even with that, even with using every single thread available on the machine, the compiler still managed to run circles around my multi-threaded solution with only a single thread. So with multi-threading completely disabled, the compiler somehow managed to find the solution much quicker than my multi-threaded solution. And not even much quicker, but instantaneously. It managed to get the solution, while the multi-threaded approach, while it was basically done right away, if you actually timed the execution, it took significantly longer than the compiler solution. Now, to understand exactly how this happened and why this happened, we first have to look at the assembly. We have to look at the assembly that the compiler generated, so we can do that through a handy-dandy tool called object dump. So if we dump the binary and view the raw assembly code, what we find is actually quite interesting, which in part is due to how I coded this example program, mainly because I was just doing it for demo purposes. So what's really interesting about this is, if you look at the code, if you look at the assembly checks to see if the number of threads I want to use is equal to 1, because that's the check I put in there, because obviously there's no sense in spinning up threads if you're only going to spin up one of them and then wait for that thread. Kind of no point. Might as well just get rid of the overhead that would accrue and just do what you would do normally. So I had to check in there if the number of threads was 1, just go from 0 to whatever the size was and calculate the sum. So the compiler recognized this, obviously, and rather than saying if the number of threads is equal to 1, go through a loop and add everything up, instead, it said if the number of threads is equal to 1, jump to this memory address. And I was like, that's interesting. So I scroll down to the memory address, and what is at that memory address? Well, it's a massive hex number. And if you convert that hex number into decimal, it just so happens to be the exact number of the sum if you summed up every one of the numbers from 0 to whatever I was going to. So the compiler literally saw what I was trying to do and was like, I got you. I'm going to convert your O of n solution into an O of 1 solution, pre-calculate the sum, and just have your code jump to there if you happen to be only running with 1 thread. You're welcome. So that is compiler optimization for you. So the reason why I was able to calculate this and essentially run instantaneously is because I hard-coded the value that I was trying to calculate, mainly because this was just for demo purposes, so there was really no incentive for me to have any kind of user input. But the thing is, once I added that user input, then the whole compiler optimization of it, doing it instantaneously, just kind of went down the tubes because it doesn't always know what the number is going to be. So honestly, though, that is pretty darn smart by the compiler to be able to recognize that and be able to automatically calculate that and put it in there. So now to try not to completely make myself feel useless, for context purposes, if you didn't run any kind of optimization at all with the compiler, it obviously wouldn't pre-compute the solution and it would go through everything. But I did try 2 different test cases. The first one was with the hard-coded solution, and the compiler got it instantly, as we mentioned. And the second one, I made it so it would only take in a value from the command line, basically forcing it not to do all of that optimization of pre-calculating the result, while also using the same optimization level flag when I compiled the program. And what I found was, if it doesn't pre-calculate the solution, it took it about 1.5 seconds or so. And my multi-threaded solution, using all the cores available, took about 0.15 seconds. So technically, if the compiler isn't cheating, my multi-threaded solution was faster, showing that multi-threading actually works. And the reason why I kind of wanted to do this example was because, generally speaking, at least in my experience, whenever people try to teach multi-threading, the examples they give are always, quite honestly, horrible and kind of make multi-threading out to be worse performance-wise, because they do we're going to have the threads sleep, and the program takes longer when you have all the threads sleeping versus if you just slept once, or they print hello world or something from each thread, which is cool and gets the point across, but it kind of doesn't, show you the gravity of how much multi-threading can improve the performance of your program. So that was kind of the whole purpose of this. And then, of course, I went down the rabbit hole of seeing that my single-threaded solution with no multi-threading was instantaneous and wiping the floor with my multi-threaded solution. Of course, I had to get to the bottom of it, and the only way I was able to do that was to look at the raw assembly and completely dump it. So here's to all you out there that think assembly is dumb. If you can at least kind of understand it, it can help you solve problems like this and figure out why your program's acting a certain way, because you can just take a look at the assembly that the compiler generated and figure out what's going on. And the last thing I want to touch on is some quick updates on the video game that I'm working on. So I'm going to keep this brief, mainly because a lot of the work that I did was quote unquote boring, if you will, since it was mainly just kind of refactoring stuff, which I've been doing quite a bit of. Because generally what happens here, at least that's what's been happening for the past couple weeks, is I figure out a feature I want to implement and then realize I already wrote that code somewhere else, and then I go pull that code, throw it into its own function, do some refactoring with it, and then implement it elsewhere. And it's a multi-step process of refactoring. But anyway, I did kind of get the learn move screen that I was talking about wanting to get. That's the groundwork's there. It's not fully implemented. There's still some logic that needs to go into it, but I need to create some other screens for that first, and that's probably going to take a while. So I decided to kind of put that on the back burner for right now. And then I also started working on the options screen. So like when you're in the overworld, you can kind of, you bring up the options screen and see all the various things you can select. And I got that at least visually working, which was actually quite simple in the sense that I did some refactoring and was able to reuse some code that I made to generate options for the dialogue, for like dialogue interactions of what you want to select. I was basically able to completely repurpose that code with some slight modifications which I did through refactoring. So basically all I had to do was write the dialogue options that I wanted for the various options on the options screen, throw that through this function that I made, and it was basically done. So that was definitely cool to see. There's definitely a lot of work that needs to be done to actually implementing all those options, but nonetheless, got at least some groundwork laid there. So now let's move into kind of the main topic that I've been kind of alluding to this whole episode, which is, what does AI think of Homelabs? So of course I mentioned that I set up a large language model in my home lab with Ollama, and I decided it would be interesting, in addition to giving me that prompt in the beginning of the Nerdy Things segment, to kind of get its insight on home labbing. And partly the reason why this happened was in the initial prompt I gave it was for that prompt of, assume you're a podcaster and you just set up a large language model in your home lab, and you're asking the large language model to give you an intro introducing the fact that you created a large language model and you wanted to ask it something. So after it did that, it was basically stuck in this mindset that it was a home lab podcaster. And rather than restarting it, I decided to just roll with it and see what AI's vision and input and insight was on home labbing. And it was actually quite interesting. So first off, it said that home labs provide an ideal setting for, well, first I had to get its software development take on it. I was like, if you're a home labber, do you do any kind of software development? And of course it was like, well, as a large language model, I don't actually write code, but, and then kind of, goes on with its answer. But it said, Homelabs provide an ideal setting for software developers to test new technologies, learn new skills, and even collaborate on open source projects with like-minded individuals. Some popular areas of software development among Homelabbers include network services, virtualization, automation, security, and web applications. Which, quite honestly, I found this pretty interesting, mainly because I've kind of touched on all of those reasons as to why software developers should have a home lab. So, for instance, on network services, It touches on some services including Nextcloud, which I personally haven't used, but I've heard fantastic things about it. I mentioned in the top open source projects that was one that I wasn't mentioning specifically because I haven't used it, but I've heard good things about it. OwnCloud, which to my understanding is kind of similar to Nextcloud. Plex Media Server to centralize and access media streaming across their home networks. Again, as a kind of alternative to Plex being Jellyfin, which I've ran both Plex and Jellyfin. Personally, I kind of tend more towards Jellyfin just because Plex has kind of done some things in the past few months to year or so that I haven't exactly been a huge fan of, but also Jellyfin allows you to do hardware transcoding without paying a lifetime subscription fee, so that was kind of appealing to me as well. As far as virtualization, it says creating and managing virtual machines using tools like Proxmox. How many times have I talked about Proxmox? ESXi, which we also happen to touch on this episode, or VirtualBox, providing a sandbox environment for testing new software, operating systems, or even setting up development environments. How many times have I given those exact reasons for why software developers should have a home lab, right? I did an entire episode of touching on why software developers should have home labs, and that was kind of the core of it, testing out software, having development environments to test things out on, learning new operating systems, the whole shebang. Here's the next one I like is automation, because it touches on scripts to automate simple tasks, backups, which heck, I've talked many times about my automated backup script that I wrote, and even using tools like Ansible. How many times have I talked about Ansible before, right? So the thing that I find really interesting when I was talking to the AI getting its input on Homelabs was it was saying a lot of the stuff that I have been saying on the podcast for a while now, which I don't know if that speaks to, what I'm saying is just common knowledge, or if it's just good advice and great minds think alike. I don't know. And then going into security, talks on including firewalls, intrusion detection systems, VPNs, to protect against potential threats, and then goes also into web applications. Obviously, if you are a web developer, having a home lab is great because you can spin up things like various web servers to test your code. You can spin up Docker containers to test your code running in there. You can deploy to a Kubernetes solution, trying to test that out in a lab. There's definitely a lot of good uses for web developers in there too. Even though I like to kind of hate on them, there are definitely a lot of uses for web developers to have a home lab here as well. So moving on to the next question I asked it, I said, what are your overall impressions of operating a home lab? And its response was, operating a home lab can be an incredibly rewarding and enjoyable experience for tech enthusiasts. Home labs provide a platform to experiment with various technologies, learn new skills, and build complex infrastructure projects within the comfort of one's own home. Some key benefits of operating a home lab include flexibility, learning opportunities, cost savings, customization, and community engagement. And then we'll continue that with its response, but I want to kind of touch on a few things that it said in there, which I found interesting. So first, it talks about it can be a rewarding and enjoyable experience for tech enthusiasts. Now, I'm pretty sure I've touched on quite a bit on the podcast of how much I enjoy operating and running my home lab and how much I enjoy it. So definitely agree there. Learning new skills, that's kind of the crux and kind of the point of why a lot of people have home labs. A lot of it is whether they want to learn, networking for a CCNA, or they want to learn security for some security certification, or they just want to run various network services, want to learn how various applications work. There's so many use cases for it, and it kind of touches on it here. The one I do like is build complex infrastructure projects within the comfort of one's own home. I mean, I guess if I can pass off me running a data center at my house as a complex infrastructure project, I guess that's another thing that we can roll with. Um, Now, going into the points it touched on, flexibility, it says that setting up your own technology stack according to your own preferences and requirements without being constrained by the limitations and costs associated with commercial hosting services or public cloud offerings. And that's honestly, quite true. I mean, if you've ever, whether for business or personal use, have ever looked at the cloud, there are a lot of options that the cloud offers, but at the same time, if you're running everything in your home lab locally, you have, like it says, a lot more flexibility of how much storage and resources you want to allocate to certain things. And definitely kind of you can choose what you want to run. Sometimes in certain cloud environments, in order to get something, you have to pay for something else. So you're not restricted to that with having a home lab. Learning opportunities, we kind of already touched that already. It talks about learning new technologies, operating systems, virtualization, networking. We kind of already touched on that. Cost savings, which I found a little counterintuitive, but when it talks about cost savings, at least in this context, it's talking about essentially you can beta test stuff in a home lab rather than going full on scaling out to a commercial hosting solution or a cloud solution. The nice thing about having the home lab is you can kind of do a proof of concept development type thing to see if it's worth doing before you scale it out. So in that sense, I get it, but when I think of cost savings, I kind of think to money involved, and I think it actually touches on later, home labs can burn money too. Customization. So this one's an interesting one that it brings up. Customizing your environment to suit your specific needs for performance, enabling you to tailor your setup to meet your unique use cases. So this is kind of nice because if you think about a lot of the cloud offerings specifically, you're kind of bucketed into tiers, right? Like if you want to get more RAM, you generally have to beef up the CPU requirements as well. If you want to beef up the CPU requirements, that generally comes with more RAM and more storage. And it's kind of a one-size-fits-all solution with a lot of these cloud providers and the tiers that they offer. And of course, as you step up each tier, that costs more and more money. But the nice thing about having a home lab is not only can you pick what devices you're running, whether do you want to run old enterprise gear, do you want to run desktops, laptops, tiny mini micro machines, Raspberry Pis, other single board computers. You have a lot more flexibility there to customize what's running in your home lab and also what resources the services that you are running actually have access to. So it's a lot easier to customize to say have your Git server, it needs however many CPU cores and RAM. And then if one day you want to, spin up some like a GitLab runner like I have running, and you realize that you're running a lot more CI/CD pipelines, for instance, continuous integration, continuous development. If you're running a lot more of those pipelines, maybe you're using a lot more resources, so you need to scale up. So you have that ability to customize, what services are using what. Community engagement, this one, I mean, I guess it basically talks about, being able to connect with like-minded individuals who share the same passion for technology. This, I mean, I get where it's coming from, but at the same time, like, you also have to be kind of plugged in to those communities as well. So it's not like if you create a home lab, you're instantly going to be connected to these various home lab communities. It's kind of like any hobby, right? Like if you get into, say music, you're not going to be instantly enshrined with the music community. You kind of have to, join a band or join an orchestra or something like that in order to kind of get that community engagement. So kind of similar with the home lab here. Like while yes, it does have the opportunity for community engagement, you also kind of have to seek that out too. So here, next, continuing on with what it talks about, it also talked about some of the challenges of having a home lab. And they say the AI says time commitment, costs, complexity, and security concerns. But it says despite these challenges, many enthusiasts find the benefits of operating a home lab far outweigh the drawbacks, providing an enjoyable, rewarding experience that can lead to valuable learning opportunities and a deeper understanding of various technologies. So, diving in a bit into the drawbacks, so it first started off with time commitment. It said setting up, configuring, and maintaining a home lab can be time consuming, especially for complex projects or dealing with unfamiliar technologies. That is a very, very true statement. So if you, I have sometimes spent multiple days trying to configure certain things in my home lab, whether that's creating a Mac OS virtual machine. I tried multiple instances, failed a few times before actually finally getting it to work. And even when I did get it to work, it took quite a bit of time. I also documented a few months ago me finally getting VLANs working. That was another instance of me trying, failing, trying again, failing, trying again, failing. A lot of trial and error, not getting it to work, sinking a lot of time in it, trying to get it to work, and then eventually I finally did get it to work. So I guess the time commitment thing, it's definitely true, but one thing I can say to help mitigate that, specifically for setting up complex projects and whatnot, is to document the process of setting up that project. So whether that's a Mac OS virtual machine, whether that's VLAN configuration, whether that's setting up some other service in your home lab like Docker or GitLab or whatever you want to run, if you document the process of how you go about doing that stuff, inevitably when you have to redo it, whether it's because you want to, you're upgrading the OS and you can't transfer things, you're migrating to a different OS and have to reset it up, whatever the case may be, you have that process documented so it doesn't hopefully take as much time as it did the first time. And even if some of the steps and procedures change, you at least have the general guideline of how to go about doing it. The next one is kind of what I thought it was talking about earlier when it was mentioning cost savings, because it also lists costs as one of the challenges. Specifically, it says while home labs can save money in some cases compared to a commercial hosting service or public cloud, they still require an initial investment in hardware, software, and ongoing maintenance costs. And this is definitely true. I mean, like I've mentioned before, home labs aren't built in a day. It's taken me years to build mine up. And if you really get into the home lab hobby, of course, it's an ever-growing thing. And even though you say your home lab's finished, we've all heard that before, just like we've heard developers say it works on my machine before. We all know probably not true. There might be a little bit of truth in there, but come on, man, you know better than that. So yeah, there's definitely the initial investment in the hardware, and then of course the maintenance costs, depending on if you're running like enterprise gear, that generally tends to be a little more power hungry. If you're running a full-on, massive network attached storage solution with tons and tons of hard drives, that's of course going to suck power. So there are definitely costs associated with running a home lab, but if you, like it mentioned, it can have some serious savings compared to, commercial hosting or public cloud offerings. Because if you do a one-to-one comparison, if you want to justify to yourself, which, let's be real, if you're a home labber, you don't really need to justify it to yourself, but you generally would need to justify it to a significant other or a roommate or someone else that has to deal with your home lab that isn't you. The one way you can pretty easily justify it is first take every service that you either are currently running or want to run in your home lab, and then price out what a comparable cloud solution would look like, and you will quickly see that self-hosting it is definitely by far the cheaper option, at least over the term of at least in the terms of the recurring costs, because at least for me, like, while I don't necessarily have many beefy VMs, like a lot of them are, barely running on anything and definitely could easily be in a cloud solution. Most of them are equipped with at least 2 cores, mainly just kind of so it's not just a single one. But if you wanted to go with 2 cores on a cloud offering, you're stepping up at least 1 or 2 tiers for that. So there's definitely some cost savings for sure doing it yourself. The next challenge it mentions is complexity. And it says Homelabs can be complex systems that require a deep understanding of various technologies and infrastructure components, making them challenging to set up and maintain for those new to the field. And I kind of get where this is coming from, but at the same time, your home lab is pretty much as only complex as you make it out to be. Now, from the aspect of understanding various technologies and infrastructure components, I kind of understand that. Like, if you've never used a hypervisor before, or you've never used a managed network switch before, yeah, that can kind of seem complex and challenging. But like I said, your home lab's only as complex as you want it to be. So, I mean, you could easily just get a dumb switch that literally the whole point is just to add more Ethernet ports. Or you could run everything on Wi-Fi if you wanted to. And then just whatever services you want to run. I mean, you don't necessarily have to make it complex. I mean, you don't have to be the guy that has 30 different VLANs in his home lab. Now, you definitely could do that for sure, but you don't have to. So it's really only as complex as you want it to be. And then the last point it touches on is security concerns. So it says specifically home labs represent a significant attack surface due to their exposed internet connections and potential for vulnerabilities in software and hardware components they utilize. Now, we've talked quite a bit in our various cybersecurity tips about how to go about mitigating this. We kind of even talked about it in this week's episode. Now, as far as home labs representing a significant attack surface due to their exposed internet connections, I mean, if you're publicly exposing everything, then yeah, absolutely it poses a serious security risk. But if you have everything, behind your network's firewall and nothing's publicly exposed, of course, there still is a risk there because, as I've mentioned, there is no such thing as a bulletproof solution when it comes to security. There is no silver bullet, otherwise everyone would be using it. You significantly reduce your risk of having any kind of security concerns if you don't have things publicly exposed and everything behind a firewall. So while that's technically, yes, a challenge and a concern, it is definitely something that can be greatly mitigated, which I guess kind of going into what it closes out with its whole remarks there. Many enthusiasts find the benefits of operating a home lab far outweigh the drawbacks, which I would personally agree with that. You may or may not, but I personally do. So then I asked it kind of as one of the last things I asked it was, since you talked about drawbacks, I asked it, aside from the challenges you mentioned, what are other downsides to owning a home lab? And it said space requirements, power consumption, noise generation, maintenance, lack of redundancy, limited scalability, compliance and security risks, initial investment, and depreciation. So I think the first 3 are quite obvious. So space requirements, obviously, there can be significant space for all the servers and network equipment, power supplies, all that good stuff. But I guess to kind of caveat that, to kind of play devil's advocate here, if you go with like kind of the tiny mini micro way, which is where you basically buy a bunch of those 1 liter PCs, your footprint honestly doesn't require that much space. It's just if you're a crazy person like me that has a full-blown rack that you kind of run into some space constraints, which I definitely have ran into that because quite honestly, in the place that I'm living right now, for whatever reason, whoever built this home that I'm in did not have the forethought to place a specific portion of the house to be dedicated for a server rack. Now, I don't know what kind of ludicrous thoughts they were thinking at the time because I don't know what sane person would not plan their house to have a, dedicated spot for their server rack, but I guess to each their own. But jokes aside, that is something that I've definitely noticed. The second one, of course, obvious power consumption. Again, this really only applies, I'd say, to if you're running kind of that older enterprise hardware that likes to suck down power. If you're running mostly like consumer grade desktop components, those generally tend to use a lot less power. Now, if you're running a large NAS with a lot of hard drives, that's obviously going to suck a lot of power too. But usually the main culprits are your beefy enterprise switches and enterprise grade servers and routers that really rack up the energy. But if you're mainly using like desktop components, that's probably not going to be a huge drawback, but definitely something. And then that kind of leads into the third one there, noise generation. Typically, the large noise generation comes from those enterprise grade servers, switches, all that good stuff. Because, if it's an enterprise grade server, it was meant to be in a rack in a data center somewhere where noise is generally not a concern. And also, data centers usually have a lot more cooling capacity than, say, your typical house would. In data centers, they have their own like air conditioning units to keep the data center nice and chilly for those servers. So there's a lot more cooling there. But in any case, if you're, like I said, if you're running more consumer grade parts, like whether it's the 1 liter PCs or old business computers like Optiplexes or whatever, noise generation is honestly probably not even going to be an issue for you. It's really only more of an issue once you kind of get into those enterprise grade stuff that was basically not designed for quietness. And then kind of getting into lack of redundancy. This one is kind of up in the air for me. Like, I get the point here. It's not as redundant as like a cloud offering where kind of all the hardware failure stuff is kind of hidden from you by the cloud provider. So there definitely is lack of redundancy in that aspect. But again, this is a home lab we're talking about. So this can be as crazy and complex as you want it to be. I mean, I know people, I've heard of stories of, people having multiple network attached storage solutions because they have their primary NAS and then they have their backup NAS, which, backs up all the data from their primary NAS, which then goes off site. So, I mean, you can definitely bake in redundancy into your home lab. So, but again, that does, come with additional cost, of course. That kind of leads into the second one, which is limited scalability. So unlike the cloud, you can't just, scale up instantly and easily. You're kind of limited by the hardware that you have in your home lab. So you definitely can increase, the number of cores or RAM allocated to a virtual machine, but you can't necessarily go to the moon and endlessly expand because you are still constrained by the hardware that your virtual machines are running on, for instance. So in that sense, you are limited as far as scalability is concerned, but from the like a smaller scale aspect, you technically aren't, but yeah, from the larger scale of being able to easily scale up applications, yeah, you're kind of limited by the hardware you have. Compliance and security risks. That was kind of already touched on. Initial investment, again, we kind of touched on that already. Setting up a home lab requires an initial investment in hardware, software, networking equipment, and other necessary components. This can be a significant financial commitment, especially for those looking to build complex infrastructure projects. I like how the AI refers to building out a data center as complex infrastructure projects. I might have to steal that from it because I don't know. It kind of makes you sound a little less weird in the sense that if you say like, oh, I run a data center at my house, that's like people are going to kind of look at you weird. But if you say, oh, I build complex infrastructure projects in my free time, I don't know. It seems like the more like fancy way of saying, like, I guess there's a couple tiers here, right? I have a home lab, which is like the one tier. I have a data center, and then you have complex infrastructure projects. I don't know. There's something about it that just sounds very like, let me raise my pinky while I drink my fancy cup of tea. I don't know. But anyway, yeah, the initial investment, definitely a major drawback to home labbing. I guess it depends on how you look at it. It's a drawback in the sense that yes, it costs a lot initially, but at the same time, it's basically like Christmas morning once that new server or that new computer arrives, because then you get to play around with it and throw a bunch of whatever you want to throw on it, and it's a lot of fun. And then here comes the last one, which is depreciation, which I get what it's going at here, because it says, as technology advances, the components used in your home lab may become outdated, requiring frequent upgrades to keep your infrastructure current and competitive. These upgrades can result in additional costs over time. So that is definitely true, but at the same time, depreciation is basically not the only, but one of the major reasons why home labs exist and are kind of worth doing in the first place, in my opinion. Because without depreciation, if you wanted to run a enterprise rack-mounted server, you would be paying thousands easily. And if you wanted to spec it out at all, you could either buy that rack-mounted server, or you could buy a new car or maybe even a new house, depending on how much you wanted to spec it up. So depreciation is also king in the home lab, because it makes these, high-end components affordable for us, once they start to get older, and the enterprises that bought them new no longer need them and are selling them off as they upgrade. So depreciation is kind of a double-edged sword there. On the one hand, yes, you will have to upgrade your home lab because your components are getting old, but at the same time, let's be honest here. You were going to upgrade your home lab anyway. You don't need the additional excuse of, oh, the hardware I'm running is depreciated and is not as powerful as it used to be, and it can't keep up with the latest and greatest stuff. Let's be real. You don't need that additional excuse. That's just the icing on the cake, because you were going to upgrade that server regardless. Let's just be honest with ourselves. So then, of course, I asked it, just kind of as we get to the end of this episode, we've kind of run quite long. But the last thing I asked is if it had any parting words for home labbing, and it says home labs have become increasingly more popular amongst tech enthusiasts to experiment with various technologies, build complex infrastructure. Again, there it goes with the complex infrastructure. To learn new skills within their comforts of their own home. They offer numerous benefits such as flexibility, cost savings, customization, learning opportunities, and community engagement. We kind of already touched that already. It's kind of summarizing itself. And then, of course, touches on there's challenges and potential drawbacks, but most home lab enthusiasts, find the benefits outweigh the drawbacks. And then it also touches on the diverse use cases that home labs can have. Touches on the proof of concept idea for businesses, kind of that thing we touched on earlier. where it can be the cost effectiveness, where it can be more cost effective to test something in a lab before you decide to scale it out to whether that's the cloud or your full on infrastructure, whatever the case may be. And then finally, it goes on and saying, carefully considering the challenges and downsides before consider the challenges and downsides before diving into a home lab. Proper planning, research, and dedication can help mitigate these challenges and create a successful and rewarding experience. Ultimately, home labs represent an exciting opportunity for technology enthusiasts to explore their passions, learn new skills, and build innovative projects in personal, flexible environment. Now, I think that's pretty much a good way to summarize it at the end there, because I know in some of the past episodes that I've talked about home labs, about getting into home labs and all that kind of stuff, it really kind of comes down to you have to kind of plan and research kind of what you want to use your home lab for, because doing that planning and researching will kind of help you overcome some of those challenges and downsides that we kind of touched on and that the AI touched on. And because if you know what you want to do, you can help mitigate a lot of that stuff. Like you can help mitigate the initial cost factor. You can mitigate the space, power, and noise factors. You can mitigate the initial investment. I mean, there's a lot of stuff you can mitigate. You can mitigate the complexity, because if you know what you want your home lab to do, you can kind of, if you know what you want it to do, what services you want to run, all that kind of stuff, you can kind of get a gist of what kind of hardware you'll need, what kind of performance you'll need, so then you can kind of get a sense of, okay, what kind of server, what kind of computer do I need to get? Do I need any networking attached with it? And if you really plan it out, you can kind of mitigate a lot of that stuff, because let's be honest, you don't need to get the latest and greatest rack mount server just to run Pi-hole and Jellyfin in your home lab. You don't. So if you know what you want to run, you can definitely kind of be able to plan out kind of your hardware components and let that dictate what you need to buy. Because let's be real, if you're going to have a home lab and you're really going to get into this, you're going to buy a lot more hardware later. So start small, and then you can kind of build up from there. Figure out what you need right now, and maybe get hardware for what you need now, plus maybe a little extra, so you can kind of grow into it. But yeah, so if you do your kind of research, you figure out what you want the home lab to do, it can definitely reduce a lot of those challenges and drawbacks that were discussed by me and by the AI and just home labbers in general. So I hope this was helpful or informative, or you got some kind of enjoyment out of this. I found it kind of interesting to kind of get the artificial intelligence running in my home lab's take on home labs, essentially getting its take on itself. I guess kind of one of the takeaways I do have was I was slightly impressed, which I don't know if I should be or not, by kind of the unbiasedness of it. Like, it was more than forthcoming to talk about downsides and challenges of owning a home lab. Like, before I even pressed it on downsides or challenges, like, it just kind of openly expressed that. Like, I mean, of course, first starting out, it was, all sunshine and rainbows. But then like when I kind of went into specifically, I said, what are your overall impressions of operating a home lab? Like, I didn't, ask for anything related to downsides. I just asked, what are your impressions of it? And in addition to giving benefits, obviously, it went directly into the challenges and gave both sides without me even asking if there are any downsides. So that was kind of nice to see. It was, I guess, a little unbiased in that sense. So that, I don't know. I thought this was kind of fun and cool to see what the AI said. I guess if you have anything that you want me to ask the artificial intelligence running in my home lab, you can let me know at contact@darkassassinsinc.com. Or if you have any other questions or topics for future episodes, you can also shoot me an email there as well, contact@darkassassinsinc.com. Link down in the show notes below. But before we leave, we should get back to our trivia question for the week. And that is, what year did the first Raspberry Pi get released? If you said 2012, congratulations, you are correct. You got this week's trivia question. Hope you enjoyed this episode. If you did, I ask that you give it a rating and review and subscribe if you haven't done so already. Definitely be sure to share this one around because I think some people would be interested not only in the Homelab content, but also what AI thinks of Homelab, because I don't know if I've seen in looking around on YouTube or podcasts if anyone's actually asked AI what its input on Homelabs is. So it might be an interesting episode for other people to listen to, whether they're interested in Homelabbing or just AI in general. Could be interesting for them. So definitely be sure to share it around. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.